I will discuss just a single formula which is applicable for all measures of location, which all of you should remember. So location can be obtained by using this formula as LLM plus in the bracket P into summation of frequencies, that is the total number of cases, divided by alpha minus cumulative frequency of previous class multiplied by class interval divided by the frequency of the class of interest. That class of interest may be like the decile class or quartile class or median class or percentile class. You note that the alpha is equal to 2 if you want to find median. So median is also a measure of location. हमने median पढ़ा था, a measure of central tendency, but it is also a measure of location because it divides the data into two equal parts. So median is first measure of location. Here alpha will be 2. So you write here 2 and P will be 1 for median. So for median, the formula becomes sigma Fi by 2, which we have learned in previous lecture. Alpha will be 4 for quartile and it will be 10 for decile and 100 for percentile. So if you want to find out the first quartile, then you will write P as 1 and alpha as 4. If you want to find out second quartile, then P will be 2 and alpha will be 4. And if you divide 4 by 2, it will become sigma Fi by 2. So second quartile is nothing but median. So it is just apart from the topic, just I want to convey you that the second quartile is nothing but median. So if you want to find out the 25th percentile, you will write P as 25 and alpha as 100. And then you execute this formula. This is a common formula for measure of location. Any doubt in this? How to apply this formula? Anybody?
No.
No, sir.
No, sir.
Okay. So this is, I think this is all for today's lecture. We want to learn this formula. What are the utilities of measures of location? Why do you want to learn about measures of location? The first utility is in the growth charts. So in pediatric age group, we want to find out whether a particular kid is growing as per norm or normal range or not. Then we use these growth charts. I have downloaded this growth chart from WHO website. It is available on this website, which is typed below in the screen. And this is for girls. So you note that there are these 5 lines. The green line is the 50th percentile of normal girls of a particular age group. So if you, let us say, if we want to find out what is the, because the 50th percentile is median, if you want to find out what is the median of normal girls at the age of 3 years, then you will find that it is about 14 kg. 3 साल की बच्चा अगर लड़की है, उसका जो मीडियन वेट है वो 14 kg होना चाहिए, because the 50th percentile here for 3 years is 14. So this is the utility of percentiles, because I will explain in the future slide today. Why do we want to use percentile or quartile instead of mean and standard deviation? So in this case, we are using the percentiles. So if a particular kid of 3 years has a weight of 10 kg, or let us say 10 kg. So 10 kg is below the 3rd percentile. So we can say that the kid is not growing properly because her weight is less than the 3rd percentile of normal girls of the age of 3 years. So this is the utilization of percentile. Similarly, percentiles are also utilized in international examinations. When you appear for examination in US or UK, then your marks will be displayed as percentiles. So that will be your location among all the students who appeared in exam. So your percentile of 90% means your location is at the 90% among all the students who appeared in exam. So this is the utilization of percentile. Similarly, this is the growth chart for boys. And for quartile, what is the utility of quartile? In the next lecture, I will talk about the measures of dispersion. One of the measure of dispersion is interquartile range. Let us say this is a data where observations are like the first observation or one of the observation is 20, another observation is 24, 25 is occurring 2 times in data, 26 in 2 times and 48 in 4 times. So if this is the data and if you plot a frequency distribution of this data, it will be a bell-shaped curve. So this is a normally distributed data. You can use any measure of dispersion for such a normally distributed data, including the range, and the range will be 20 to 80 because the lowest observation is 20 and the highest observation is 80. You can also use the 2 standard deviations from mean as a measure of dispersion, and you can also use interquartile range. So what is interquartile range? I will discuss more about interquartile range in my next lecture, but the coming slide will tell you more about interquartile range. So if this data is normally distributed, so if let us say data is like this, so 1 is occurring 1 times, 2 is occurring 2 times, 3 is occurring 3 times, 4 is occurring 4 times. And if you plot the frequency distribution of this data, you will find that this portion is like a bell shape, but there is one value 98, which is far away from these values. And our curve is extending up to this side. So this is a right skewed data. So skewness, we talked a little bit about skewness in previous lecture. So this is right skewed data, and if you use range to describe this data, then the range will be from 1 to 98. Will it be justified to describe the data as that most of the observations are between 1 to 98, 1 to 98? I don't think that it is the appropriate way, because most of the observations are between 1 and 8. So in such a situation, when data is not normally distributed, we can trim out the extreme values from both sides, and we can then, after trimming, the range which is left, we can use that range. So one of the methods for utilizing such a range is known as interquartile range. So if you calculate quartiles of this data, the 25th quartile is 4, and the 75th quartile, the second quartile is 4, and the third quartile is 6. So most of the data is between 4 to 6 is more appropriate than describing this data as from 1 to 98, because most of the observations are at the lower side. Any problem up till now?
No, sir.
No, sir.
No.
So this is the end.